Hello everyone, welcome back to the channel Code Tag Management. So today we are gonna discuss with one of the important scenario based questions actually which backend engineers used to face during their interviews, and that is also one common scenario during your projects as well. So just imagine the scenario like it's Friday evening and your team has just deployed the latest version of a Spring Boot application to production. So everything looked perfect during testing. The deployment also completed successfully and there were no errors and all health checks passed. But within a few minutes, users start reporting that the application has become extremely slow. APIs that were previously responding in 100 milliseconds are now taking all about like 2 or 3 seconds. So customer support starts receiving complaints, dashboard actually showing the increasing response times, and suddenly everyone is asking the same question, like what changed after deployment, right? So now this is one of the most common production scenarios backend engineers face. The biggest mistake many developers make is like immediately assume that database is slow, but in reality API latency can increase due to many different reasons: code changes, configuration changes, infrastructure issues, JVM problems, database bottlenecks, thread pool exhaustion, or even a slow downstream service as well. So in today's video, I am going to show you the exact production debugging approach that experienced backend engineers follow. So this is also a very common interview question for developers with like 4 to 8 years of experience. So let's get started. So first of all, confirm whether the deployment is actually responsible or not. Like confirm whether the deployment caused the issue. So the first thing I always do is verify whether the deployment is actually related to the problem. So never assume that because the issue appeared after deployment, the deployment is definitely the root cause. So ask a few simple questions. So did the latency start immediately after deployment? Did anything else change at the same time? Was there an infrastructure upgrade? Was there a database maintenance activity? Was a configuration updated? Was traffic unusually high? So next compare the current deployment with the previous stable version. So look at the deployment time, git commit, release notes, and configuration differences. So if version is 2.1 had an average response time of like 120 milliseconds, and suppose version 2.2 suddenly jumps to 900 milliseconds to 1 second. So immediately after deployment, then you have established a strong correlation. So remember, correlation doesn't always mean the causation. So, but it gives you a starting point. So just assume that that is only the cause or the pain point, but you will get some idea, preliminary idea from that. Next is like check the monitoring dashboard. So like once I have confirmed the timeline, I don't jump into the logs immediately. Instead, I open my monitoring dashboards like Dynatrace, it can be Grafana, many things, Datadog, many tools are there. So tools like Grafana, Prometheus, Datadog, Azure Monitor, or New Relic give me a high level overview of the application's health. The first metric I check the CPU utilization. So if CPU usage suddenly jumps from 30% to 95% or more than that after deployment, so it tells me that the application is doing much more work than before. So maybe an expensive loop was introduced, maybe JSON's realization became heavier, or maybe an inefficient algorithm was deployed. So next I check memory usage. So if heap memory continuously grows without dropping, that could indicate a memory leak or excessive object creation. So after memory, I'll check the garbage collection. So long full garbage collection pauses are one of the most overlooked reasons for high API latency. So imagine every few seconds the JVM pauses for 700 milliseconds just to clean the memory. So during that pause, every request has to wait. And finally, I check the thread utilization. So suppose the application has a Tomcat thread pool of like 200 threads and 198 threads are already busy. So new incoming requests now have to wait for a free thread. So increasing the latency even though the application itself is not crashing. So these metrics help me quickly determine whether the issue is related to CPU, memory, garbage collections, or thread exhaustion. So these points are very much important. What you will look from the uh, monitoring dashboards: CPU utilization, memory usage, then garbage collection, then thread utilization. Next, identify which APIs are slow. So the next step is identifying the scope of the problem. Like, is every API slow or is only one endpoint affected? So this question is extremely important. So the payment, suppose the payment API is taking 3 seconds, while the user profile API still responds within 100 milliseconds. So now I know the issue is isolated that and it's specific to the payment flow. So maybe the payment gateway is slow. Maybe there is a new validation process is there. Maybe additional database query was introduced. So on the other hand, if every API in the application is slow, then the problem is probably related to the infrastructure, JVM performance, database connectivity, or thread pools. But narrowing the problem scope saves a huge amount of debugging time. Now review the application's logs. So see, not in the first step, I will see the application logs at the step 4. So now it's time to inspect the application log. So I search for warnings and error messages, even if users are not seeing errors. Warning logs often like reveal hidden performance problems. So some common message I look for include socket timeout, read timeout, connection refused, SQL timeout, or like out of memory error or repeated retry attempts. So I also check whether a particular exception started appearing immediately after deployment. Sometimes a downstream service is timing out, causing retries, and every retry adds some extra latency to the request. So logs help confirm whether the application is experiencing like internal failures or waiting on external components. So through the log, we can get some knowledge from that. Next, I will check the database performance. So the next component I investigate is database. So many developers immediately blame the database, but I always verify with evidence. First, I check the slow query log. Like, did any query suddenly become slower after deployment? Then I analyze the execution plan using like explain analyze. So I am looking for full table scans, missing indexes, inefficient joins, or sorting operations over millions of records. So next I check for the database locks. So a long running transaction can block other transactions, causing every API request to wait. So finally I inspect the database connection pool. So suppose Hikari connection pool allows only 20 database connections. So if all 20 are occupied, new requests must wait for a connection before they can execute any SQL query. So even a perfectly optimized query becomes slow if no database connection is available, right? Next, I will check the downstream services. So like modern microservice applications rarely work in isolation. So a single API request may call multiple downstream services. For example, an order API might communicate with the inventory, payment, notification, user services. So your own application might complete its work in just 100 milliseconds. The database query might take another 50 milliseconds. But if the payment service takes like 3 seconds to respond, the entire API now takes over 3 seconds. The problem is not your application, it's the downstream dependency. So this is why distributed tracing tools like OpenTelemetry or Zipkin or some Zygar. Several tools are there. So those are actually valuable. So in my project, we have used like OpenTelemetry. So for distributed tracing, and also we have used one micrometer as well. So they basically show exactly where the request spends its time. Next, we have to check the JVM health and thread dumps. So if everything looks normal so far, so I investigate the JVM itself. So I monitor heap usage, garbage collection frequency, thread count, CPU utilization. So if necessary, I capture a thread dump using JStack. Thread dumps basically show what every thread is doing. Are threads actively processing requests, or are they waiting for the database, waiting for the Redis, or waiting for an external API? So blocked by a synchronized lock, that is also happening or not. So suppose I find that 180 out of 200 threads are waiting for the database connection. So now I know the application is not actually slow. So it's waiting for another resource. So thread dumps often reveal the problems that are impossible to identify from logs alone, right? Next, we'll verify the actually we'll do check the infrastructure as well. Okay, so there basically I verify the infrastructure. Sometimes the application code is completely fine, but the environment has changed. I check Kubernetes pods, restart count, CPU and memory limits, load balancer health, network latency, DNS configuration, or suppose auto scaling events. So sometimes one unhealthy pod is receiving request and causing high latency, while the remaining pods are perfectly healthy, but they are not getting the request to process. So infrastructure should always be part of your investigation. So apart from that, we'll compare the before and after deployments as well. And there we will compare the CPU usage, memory usage, garbage collection, pause time, thread count, database query time, etc., etc. And we will decide the next action items like possible action includes like roll back the deployment if a recent code change caused the issue, optimize the slow database queries or add missing indexes, fix the configuration issues such as connection pool or thread pool sizes, increase the timeouts or optimize communications with downstream services, resolve memory leaks or JVM tuning issues, will scale infrastructure if the system is resource constraint. So whenever API latency suddenly increases after deployment, don't panic and don't immediately blame the database. So follow a structured debugging process. First confirm the deployment timeline, then check the application metrics, identify which APIs are affected, review the logs, analyze the database performance, inspect downstream services, verify JVM health, capture thread dumps if necessary, finally check the infrastructure. Production debugging is all about collecting the evidence and eliminating the possibilities one by one. So that's exactly how experienced backend engineers solve the problem in real production environments, and that's also the approach interviewers expect during system design and Spring Boot interviews. So if you found this video helpful, don't forget to like, share, and subscribe to Code Tab Management. And in the next episode, we will discuss another popular production debugging interview question like database connection pool gets exhausted. So, like what could be the reason? So, we will discuss this type of many more scenario-based questions. And personally, I have faced many such scenarios during my last 5 to 6 years. So thanks for watching, and I will see you in the next video.